Hello, this video lecture is meant to do two things. So first is to review the concept of a circuit, and then the second one is to differentiate between DC and AC. So direct current and AC current. Okay? So so here I have a virtual circuit maker. So what we do is we can have a load such as a bulb. We can place a bulb here, and then we construct our circuit by adding some wires into it like so. And then we add also our power source, the one that makes the electricity flow. So I have here a battery. By the way, in this battery, the black end is positive and the gray end is negative, right? So we'll complete the circuit, and for this case, we don't even need a switch. We just simply complete the circuits like this. One, two, three, go. So here you see that these are electrons. The electrons are flowing around the circuit, and the electrons are flowing because this one, the source, the power source, or the voltage source is pushing the electrons to flow, right? In this case, this is an example of a direct current voltage source, so DC source. So a battery is an example of a DC source, right? So a direct current source. So if you notice in a direct current source, the electrons are pushed to flow in one direction, right? And it's important to take note that this direction is from the negative end of the battery, right? They flow around the circuit and then they wind up entering back to the positive side of the battery. So this is always the flow in terms of electrical flow or electron flow current. The current is flowing from the negative side of the battery, moving around the circuit and entering the positive side of the battery. By the way, that is also the basic concept of a circuit. When you say circuit, that comes from the word circle or loop. So therefore, to create a circuit, it must be something that is completely closed in a loop. So you see, there's a closed loop wherein the electrons can flow. If I were to create a gap, for example, right now, it's not a closed loop, right? Because this one is open here, the electrons can't flow from here to here, there's no connecting wire, it's not a circuit, right? So this is the basic concept of a circuit. It must be a closed loop consisting of something that pushes the electrons to flow, gives power or energy to them, called the voltage source, and also uh, a device that consumes, or not consumes, but uses the electrical energy to convert it to other forms. We call this the load, and obviously the connecting wires. But if you see, even if you have a load, a voltage source, and connecting wires, if you don't close it in a loop, it's not a circuit. So that's important. That's why we call it a circuit. That comes from the word circle, or it must be in a closed loop. Okay? Now, important part, because electrons flow from the negative side of the battery around the circuit and entering the positive side, that means if we have a battery like this and then we switch its polarity such that the positive side is now on the other side like this, notice that the flow of the electrons is one, two, three, go. Now reverses. Now it's clockwise, right? From this perspective. But that's because the orientation of the battery has now changed. The negative side is now on this side, so obviously electrons still do go out from the negative side, closing the circuit in a loop and then entering the positive side. Okay? So one more time, let's switch the direction of the battery. This time the positive side is in this side. Now, if we do that, the flow is now again counterclockwise because the negative side is here. Okay, so that's a DC circuit. So remember, a DC or a DC power source, a DC voltage source pushes the electrons to flow only in one direction, and that direction is usually out from the negative side of the battery into the circuit and entering again at the positive side of the battery. So it depends on how you orient the battery, because if the battery is switched, then the direction is also switched. But make no mistake, in one setup, there's only one direction of flow of electrons. That's why it's called direct current. The electrons flow in one direct route or one direct direction. Okay? Now, if we have an AC source like this, it's much different. By the way, an AC source, the most common AC source is obviously your outlet at your houses, the outlet where you plug in your TV and your other appliances. That's an AC source. Now, let's observe what happens on AC to a circuit powered by an AC power supply or AC voltage source. One, two, three, go. See? Notice this a very note this there's a um, very obvious difference between DC source and an AC source. An AC source pushes the electrons one way, but it reverses and pushes it in the other way. So in a way, an AC source really uh, oscillates the electrons back and forth. So it pushes the electrons forward and then back to the opposite direction and then back to the opposite direction, kind of in an oscillating pattern. It oscillates the electrons back and forth. So that is the main difference between AC and DC. From true to its namesake, alternating current, that means the electrons are pushed in such a way that its direction of movement is alternating. It moves forward and then backwards and then moves forward and then backwards and then moves forward and then backwards. So the direction is alternating. That's why it's called alternating current. So to review, a circuit is a closed loop wherein there is a power voltage source that can push the electrons to flow, and there's also a load that consumes the energy, the electrical energy to convert it to other forms of energy. And you cannot make a circuit without making a closed loop. Second, that there are two types of source of voltage sources. One is an AC source, an alternating current source. It produces a current that alternates in direction. And one that is a DC source, such as a battery, and it only pushes the electrons to flow in one direction, and it's always coming out in terms of electron flow, coming out from the negative side of the battery, traveling around the circuit and then entering the positive side of the battery. um, so that would be it. I hope from that video lecture you learned about the most basic concept about circuits and the difference between AC and DC sources. Later on, when we fully discuss about electromagnetism, whether you use a DC or an AC source matters to what magnetism it creates. Okay, so you should remember them.